Welcome back, everyone. This is ARC4CFD Section 1, Lecture 3. So in this lecture, we will go even further into the interacting with the cluster. Today, we'll actually learn how to successfully run job in the HPC system. So the goals for today, for this lecture, are how to allocate successfully resources on the cluster using Slurm, how to run jobs, and we will see a couple of ways. We have interactive mode and submitting batch scripts to the job scheduler. And finally, we will answer the question, but what happens to softwares on the cluster? How do I use them on the cluster? Okay, so the first thing is Slurm. Once again, Slurm is the workload manager, is very common among several HPC systems, not only the Alliance one, but even worldwide is pretty common to have Slurm as a workload manager. And throughout this class, we will see how to interact with Slurm, how to allocate resources, and what are the most common commands to run to interact with Slurm. Three of them are shown here. salloc is the command to actually allocate resources. So you can ask Slurm to give you, for example, 32 nodes to do some sort of computation. That is done through the use of this command. And then we have the sq um, command, which is used to actually monitor your simulation after they are started and they are running. So let's say you have a few jobs running, most likely you will be running more than one job at the same time. Then with this command, you can actually check how the jobs are doing, if they happen to have crashed or something like that. This is done by using this command. And finally, we have sbatched, which is the command to run the simulation. So you will, in this case, you will write a script with all the directives that you want to give Slurm with respect to that specific job, and then you give this command, and the job will be submitted. So we have basically two types of ways of running jobs in the cluster. We have interactive jobs, which think of it as supervised jobs. So basically what you do is you use the salloc command to allocate whatever resources you need, let's say 15 nodes, for example, and you will be put physically into these 15 nodes. So basically, your connection will shift from the login nodes to the compute nodes. And after that, you will be sitting on the compute nodes and you can directly execute your program. The program will run inside your terminal session. The moment you turn off the computer or kill the terminal session, the job will be killed as well. So these are supervised job. Then we have a batch or unsupervised job, which is pretty big in this slide because the reason is that this is the most common way of actually running jobs on and running simulation on the HPC system, which is basically you write a small script with all the directives and information of the job to give to Slurm, and then you submit it as a batch script, and then the job scheduler will take care of basically everything, allocating the resources and running the job. The execution line will be put inside this batch script. So these are unsupervised jobs. Because unsupervised, because at that point, once the job has been submitted, it's been handed to the queue manager, and then you can turn off your computer, you can go away, you can check later, you can connect from another device, and you can use the sq command to actually monitor the simulation. And then the big question is, but I am very much used on using my software, for visualization, to run simulation, or to do some processing or pre-processing, for example, Python or OpenFOAM and ParaView. So what happens? Do I have to install them in the cluster? I mean, it sounds like a lot of work. Well, the answer is you don't, because in the Alliance HPC systems, we have a wonderful system to actually save you a lot of work, which is the module system. Most of the software that you will probably use in your research are already installed in the cluster in a form of a module. Think of it as a package. You only need to basically take this package and put it in your profile or in your current session. Okay, with basically what basically that is a module load operation. Okay, so if you want to use ParaView, for example, you would do module load ParaView, and you can load whatever version of ParaView you want to use. Same thing goes for OpenFOAM and Python, and this all will be explained in this lecture. Once again, I acknowledge the collaboration between MPI Lab, Computer Ontario, and University of Waterloo for this course, and I would see you next lecture.